Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional video for Math 152 in regards to how to use the Chapter 10 Excel template that I created for doing linear regression. This template is located on Moodle under Chapter 10. So if you open it up, it looks like this. You will put the paired data in the highlighted section from the problem. You will then receive a scatter plot, a linear correlation coefficient R, the results of the correlation hypothesis test. You will also get a regression equation for the paired data. And then if you would like to make a prediction, you could put your predicted value X here, and then the regression based off of the prediction based off of the regression equation, or if there is no correlation, you will also receive the mean of the y values, which is located here. Okay, so let's use one of our homework problems as kind of our guide. So here is data on intervals after an eruption of a geyser. So you're given height, and then essentially time between eruptions, and it says find the regression equation. Let the first variable be the independent variable x, which will be height. The best predicted time of the interval after an eruption, given that the current eruption has a height of 68 feet, and so we're going to make a prediction on 68 feet. So essentially the time till the next eruption if the previous eruption had a height of 68 feet, and we were going to use a significance level of 0.05. Alright, so first thing is to copy this data into the template. So if you click on the little blue box, you can open the data in Excel. It will open in a new spreadsheet. My computer is incredibly slow. Finally. Okay, so in the template, take the data that's in there out. Then you want to copy the data from the problem, paste it into the template, and then you should pretty much instantaneously see a scatter plot, your linear correlation coefficient, and your regression equation. So everything should pretty much come up for you. So the first question says, what is the regression equation? Okay. So let's go back to the template. So the regression equation is this blue dotted line. So that is the line of best fit. That is the linear equation of a line that goes through pretty much the middle of the data points, and we use that as a predictor. And the equation is located here on the scatter plot. It's also located here in your Excel template. This value is the y-intercept. This value is the slope of the regression equation. And so you just want to make sure that you put those values in so that it matches. So you want to put the y-intercept in first. It says round to 2 decimal places. So that would be 42.87. That's this value here, 42.87. It's also listed here just in case you're having a hard time finding it. And then the slope goes in front of x. We also want to round that to 2 decimal places. And so that slope is located here. It's also located here in the equation. So 0.32. Okay. And then it says, what is the best predicted time for the interval after the eruption that is 68 feet high? So we go to our template, and we have to read the results of the hypothesis test, and that's why they gave us a value of alpha. The hypothesis test that I have in this template is based off of an alpha of 0.05, since that is what is most frequently used. And so you want to look at the p-value that's associated with your test statistic here. So notice you use this p-value if the test statistic is positive. Use this p-value if the test statistic is negative. So our test statistic is positive, so we're looking at this p-value. And then, just like any hypothesis test, compare the p-value to the level of alpha. So alpha is 0.05, our p-value is 0.02302. That is less than alpha. So because our p-value is less than alpha, that gives us evidence to reject the null hypothesis. And for the linear correlation hypothesis test that you did in section 2, recall that the null hypothesis is that rho is equal to 0, which would imply there's no linear correlation. So this gives us enough evidence to reject the null and accept the alternative that rho is not equal to 0, which would imply that there is a linear correlation. So if there is a linear correlation between our paired data, then we can use our regression equation as a predictor. Okay. If there is not a linear correlation, so let's say that our p-value was greater than alpha, then we would not be able to use this regression equation as a predictor, since the regression equation is based on the idea that the data is correlated, and the best estimate would be y bar, which is the mean of the y coordinates. So basically it's just the average of these numbers right here. So you actually have to look at the results of the test before you can then determine whether it's warranted to use the regression equation. So in this case, since p-value is less than alpha, right, we rejected the null in the hypothesis test, which is all about what you did in section 2, right? Then we could use the regression equation as a predictor. So then you would want to put the value that you are predicting for x, and so in this case we are predicting a height of 68 feet. So I would want to change this from 92 to 68. And then notice that that will essentially plug this value of 68 in for x into this regression equation, and then this is the predictor that we found based off of the regression equation. So this is the predicted wait time until the next eruption if the previous eruption had a height of 68 feet. So then we would essentially be waiting around 65 minutes for the next eruption of this geyser. So that's what this is telling us. So let's see what we're rounding to here. Round to 1 decimal place. So 64.8. Okay. So that's how you use the template for section 3. Just keep in mind, right, that you have to still interpret the results of this hypothesis test so that you can then make a decision whether you can use the regression equation or not, right? If your p-value is greater than the level of alpha, you cannot use the regression equation. You would use y bar, which is the average of the y coordinates, as the predictor, right? If your p-value is less than alpha, then you could use the regression equation, which you could then use the value of y that you get from the regression equation when plugging this value in for x. So just keep that in mind. Alright, if you have any questions in regards to using the template or anything in regards to section 3, please email me and I will answer your questions promptly. Alright, thank you and have a great day.